Hello everyone, and welcome to the continuation of our programming the finite element method using MATLAB. In this video, we are going to continue our efforts in producing finite element objects from our nodes. In the last video, we were able to create the master nodes from the str nodes, and we were able to view them via the viewer, which I will now promptly hide because I don't want it to use my precious resources from the computer. Now, to continue our efforts, we need to continue with the create fem objects from str nodes. We are on the str controller, we're standing here, and we created for each individual node a master fem node. But that's not enough, because yes, we have created the master fem nodes, but there are also slave fem nodes. Now why is that? It's because of supports. But before we dive into the video, I want to quickly give the information about the fact that this is part of a playlist in the Finite Element Method series, which I will be linking on the top right, and it's also its own programming series by itself, which is also linked on the top right. And of course, as per usual, channel members have access to this source code, but if you are not a channel member, then don't worry, because every single line I write here will be written in front of you, so you can write along and you will have the exact same copy of my own code. So with that being said, and without further ado, sit back, relax, and enjoy the show. Okay, now we are still creating our finite element objects from the str nodes. We created the fem master nodes, but that's not enough, because I want to see if the node is supported. Because if the node is supported, then this needs to create a spring to deal with the support. If it's rigid, if it's free, it needs a spring. So here, I'm going to ask the question. If is object node.support, so if the field node.support is an object, I'm talking about this field, or this property. If this property is an object and not empty, this means that this node is supported, and we need to deal with it. So here I will say, indeed, the node is supported, and we need to deal with it. So how do we deal with it? We are gonna do the following. For the str node that has a support, there will be a master fem node that is existing, and besides the master fem node, I am going to add a slave node. It's only a small distance away from the master node, and the connection between the master node and the slave node, I'm talking about the fem here, is going to be a spring. And the values of the stiffness of the spring depend on the support. Because remember, I am going to assume that a rigid support has a very high stiffness and that a free support has almost no stiffness. Now this is not the cleanest way of doing things, but this is the most practical, so I'll be using this approach. Now, since there is a support, I must create a new fem node beside the original master fem node. Now I need to make sure that my slave node is not too close to my master node, because if it is too close, it might trigger the problem that it considers it's only one node. So I need to be careful with that. I think that I should not be using the normal epsilon for my fem calculations. I think that I should be using a much smaller epsilon for my fem calculations. So let's say this epsilon is 10 power minus 4, and that the fem epsilon is smaller than this. It's 1e times negative 5. Because I'm going to use a smaller step for the finite element analysis than the step that is used for the structural modeling. Now those are values I chose. You can change them, and you can see the effect of changing them on your structure. Now I have a fem epsilon. This changes some things. For example, in the definition of a new fem node, I was comparing it by using the normal epsilon. But now, since I'm using the fem epsilon, all those epsilons change to fem epsilon, because I'm using a higher accuracy for fem calculations than for the structural modeling. Now, since we included the fem epsilon, now when I go here to the creation of my slave node, I'm gonna shift it. Let's create, so I will create here a slave fem node that is shifted more than the fem epsilon. Because if it is shifted less than the fem epsilon, then the programmed trigger is going to activate where it will not define a new node because it's in very close proximity of the original master node, so it merges them and those two become one. This will cause havoc in the finite element analysis because you cannot have a spring between a node and itself. It doesn't work like that. So I need to space it out. How do I space it out? Well, to be honest, I'm not sure. Let me remember how I can do this. So CLC, if I say random, I get a random between 0 and 1, right? This is MATLAB. If I say random, gives me a random number between 0 and 1. Okay, so let's say I want a random number between 0 and 1,000. Okay, so let's find a random number. Random between 0 and 1,000 means random multiplied by 1,000. This gives me something between 0 and 1,000. Let's see. Random times 1,000 will always give me a number between 0 and 1,000. Okay? So this number I will multiply by the fem epsilon, object.fem epsilon, to get the spacing. So this means that my slave node is going to be spaced away from my master node by a value between 0 and 1,000 epsilons. That's not good because there is a chance I would land below the fem epsilon and will trigger the duplicate node effect. So I need a failsafe for that. Let me say here delta or small distance. This equals random multiplied by 1,000 multiplied by object fem epsilon. Now this is small distance. Now I'm afraid that this might trigger the fem epsilon safety net. Because if by chance this is less than fem epsilon, then it will not define a new node, right? So I need to make sure it's not less than fem epsilon. So I'll say here small distance is the maximum between itself and 1.1 fem epsilon times fem epsilon. I cannot use fem epsilon because this would still trigger the warning system. I'll go for 1.1 fem epsilon. So at least now the small distance is always going to be more than fem epsilon and it's going to be random. Okay, fantastic. Now this small distance we're going to use to define a new node. How am I going to define my new node? I need the coordinates of the new node, right? So what I will be doing is I will go here and say fem, let me just put here a comment and say define slave node using master node and small distance. So what I will do here is I will say fem slave node, this equals, I don't know, object.add fem node, and it wants for me the x and y and z, right? So what I will be doing is I will be shifting the x of the node a small distance to kind of make it beside the original node in the x. I think that's what I'm going to do. So here I'm going to take node x or node.x, and I'm not going to use it because look, let me show you. If you use node x, node y, and node z, this will not work. You know why this will not work? Because this is a carbon copy of the master fem node, so the safety net will trigger and it will not give you a new node, it will just reuse this. It doesn't work. So I need to shift to the small distance, and that's the reason why the small distance must be more than the fem epsilon. Because if it's less than the fem epsilon, then in the fem node addition, if you see here in the add fem node, let me show you, the safety system will trigger. I don't want the safety system to trigger, so I must make sure that my extra increment distance is more than the safety net, and that's what I have done here. Now this is the fem slave node. I defined it, and now I need to start changing its things, basically, its stuff. So here in the fem slave node, I need to set some things. Now first of all, for the fem slave node, let's set the is master node. I can basically copy this entire thing, but I will set it one by one. I'm going to set the same thing here for this slave node now. So is master node, well, that's a glaring false. It's not a master node, of course. Now fem slave node dot is support node, and that's a glaring true because the support is at that node. Then fem slave node dot is slave node. That's a true because it is indeed a slave node. Then fem slave node dot slave fem node. That's a no because it is the slave. It doesn't have a slave. However, it has a master. I would say here, what should I say? I should say here, fem slave node. Am I missing something? Okay. Master fem node equals, now we need to set this fem master node as a master to this slave node. They always need to know each other. So here I will go and say fem master node is the master of the slave node. So I put a reference to that thing. Also, since I have a slave node, this means that I need to set the slave node of the master node, meaning I would go here and say fem master node, and for the slave fem node, I'm going to add the fem slave node. In the beginning here, I added nothing because I did not know if it has a slave or not. Now, if there is a support, I am creating a slave, so now the slave node that I did not know in the beginning is now something I do know. But there is something missing here. Let me see. Corresponding stuff. So here I would say fem slave node dot corresponding str node. That's still our dear node that started this entire heading, which is this dude. Now I defined my master node. I defined my slave node. What remains is to define a spring between the master node and the fem node, but that's a topic for another video. Before I finish this video, I'm gonna go back to my dear viewer and see if it does indeed add those slave nodes and if it is even running. So let's remove those comments, push the F5 button, and there is no error at least, so that's a good thing. Let's take a look at the figure. You cannot see it. Of course you cannot see it because it's so close, but how can I see it? Let me just zoom in. Can I zoom in? Maybe I can let the reporting system report it to me and then I can see it. I think the view will not be the solution to seeing this because the distance is so small. Maybe I can let the reporting system report it for me. So on the controller, I still haven't added the fem nodes to the reporting system. To be honest, I didn't intend to do that, but since we want to debug, I'm gonna add the fem node to my reporting system. I kind of don't want that, but it's just for debugging. So I'll just copy this thing, paste it here. I don't know, copy this thing, paste it here, and call here fem nodes. Fem nodes. And here I will pass through every single one of those fem nodes. I'm gonna fish it out to become the target fem node and paste it here. So now the str nodes are 8. So the fem nodes should be 10 so far because I'm adding 2 fem nodes because I have 2 supports. Now let's run and hope that it works somehow. So I'm running it now. Is it running? It's not running. CLC. Oh yeah, of course, I need to go main. Main and run. Let's hope I see 10. Come on, man. Come on, dude. I see 10. Yes. Fantastic. I saw something else. I saw this. What's this? What are those? Are they remnants of my testing? Oh yeah, okay, yeah. Those are the remnants of my testing. Let me delete this for now. Let's keep the testing area, but I will test something else later. Let's run again and make sure I see everything as it's supposed to be. So in the fem nodes, let's take a look. So fem node 1, I think I should also say what is slave or master it is. I think I also should report if it's a slave or master node just to be able to see. Oh, I can actually see it here, look. This is 0, and that's a 0.0, and this is the slave node. Am I missing something? Wait, let me try it. I want to see it better. Maybe I can increase the accuracy, maybe. Let's increase it to, I don't know, 6 values after the dot and make this become 9. So I'm increasing the accuracy of the output for fem nodes, hoping that I can see those little things I added. Let me just Control V here and F5 again. Okay, there is an error. Oh yeah, I need to go to main. That's true. I hope I can see those little changes. So I think I messed up. Yeah, I messed up. Yeah. I changed the fem node. I should have changed the, oh my God. I should have changed the str. I should have changed the fem node. I changed the str node. So let's Control Z, Control Z, Control Z, Control Z, and go to fem node and change that thing. Oh, what a bummer. What a noobish error. Control V. And now let's run again, and I hope I can see the slave nodes in action. So let's run it. Okay, it's reporting. Let's take a look. So this is node number 1, and that's the slave to node number 1, a small increment, that's right. Node, look at this. This is pretty cool. Look at the numbering system. Those are 2 numbering systems. Let me explain this to you. Let me open the viewer. Although you will not be able to see it, but it's just worth a try. So let me just try explain it to you. Okay, the viewer is loading. So there we go. Now, let me count for you the str nodes. The str nodes are 1, 2, 3, 4, 5, 6, maybe 7, and 8. I don't know which one is 7, which one is 8. But in the fem nodes, I would have 10. Why? Because the counting system is a little bit different. This is 0. Sorry, this is node number 1. And also very close to it is node number 2, which is the support. Because there is a support. That's 3. That's 4. That's 5 and 6 because of the support. That's 7. That's 8. That's 9. And that's 10. Let's take a look. So that's 1 and 2 for its slave. And that's 5 and 6 with its slave. And yeah, I think it makes sense. I think it does make sense. Yep. So I guess good job. I can pat myself on the back. I'm surprised by this. This should be first. I'll worry about this later. I'm very surprised about the way it does things. It doesn't matter now. So yeah, that's everything I wanted to talk about today. I hope you enjoyed. And in the end, I want to give a fem node sized shout out to my dear channel members in the contributor level and the helper level whose names are going to be shown on the screen. I want to thank them from the bottom of my heart, as their support of the channel is priceless to me and enables me to provide you with videos hopefully on time and with a certain quality I try to achieve, and for that I am forever thankful. In the end, I hope that you enjoyed the video and you found it beneficial. If you have enjoyed the video, then please consider liking, sharing, subscribing, commenting, and so on, especially subscribing because it helps increase the reach of my channel. As per usual, this is the Civil Engineering Essentials channel, and we'll catch you in the next video. Bye bye.